now be recorded.
Hi everyone, good evening. How are you all? I hope everyone is doing fine and welcome to InfosecTrain, guys. So today we are here for the bootcamp for cybersecurity essentials. Now, guys, before starting our course, before proceeding to our agenda, let me introduce myself. My name is Ashish Dhyani. I'm working as a trainer in InfosecTrain, and I have around 4.5 years of experience in total in this particular field. Now, talking about my certifications, so I'm Network Plus certified, I'm Linux Plus certified, I'm Server Plus certified, I'm CH certified, I'm CND certified, I'm CCNA certified, I'm Pentest Plus certified. Apart from these, I'm ECSA certified as well, and I do take care of web application pen testing and network security pen testing as well. Right? Okay. So, talking about my background, guys. So, I have given trainings to government and non-government organizations as well. I have given done pen testings for government and non-government organizations as well, and I have given trainings for that as well, right? How to do pen testing and how to perform pen testings, right? So now moving on to our agenda of the course, what we have is what we have is we have this thing. Right? So, is my screen visible to everyone?
Yes, you're
Yes.
audible.
Okay. So we have this agenda for the webinar, right? Miss Sushmita, will you please mute yourself? Okay. So guys, please mute yourself because there is a lot of background noise coming. So others will be disturbed. So that's why. If you guys have any queries, you can put all those queries in the chat as well. So this is the agenda for us. So this is a 5-day webinar and we will be starting with the day one, and on day one what we will be learning, with the basics of networking. Now in basics of networking we will start with the very basics, that what is a network, then your network standard models, what models do we have, now network topologies, what topologies are, how we use topologies, and then we will be moving on to the types of networks. Now moving on to the types of networks, what we have, like LAN, WAN and MAN, right? Now next thing that we have is, guys, networking devices. So in networking devices we will be discussing about switches, hubs and routers, right? Next thing that we have is IPv4 addressing. So what is IP address and how we get the IP address and how the subnetting happens? So we are talking about that. We will be talking about in terms of that. And then we have IPv6. So I will be giving you the overview of IPv6, that what is IPv6 and why we moved from IPv4 to IPv6, right? Then after that, on day two, we will be discussing about the Linux bases, and in that I will be telling you guys that how to install VMware, what is the history of Linux, and the architecture of Linux that we follow. Then we have basic commands, that what are the basic commands that we have. Then we will be learning about the basic commands and the file management, and then using the redirection, how to redirect your output as well, and if there is any error, how to redirect that as well. How to combine two commands with using pipes, that we will be talking in terms of that, right? Then next thing in the day 2, the last thing we will be talking about network troubleshooting commands, that if there is a problem in your network, so what tools you guys will be using to troubleshoot those things, right? After that, basics of security we will be talking about. So what is the security, the security factors. Now, understanding basic security terminologies, what types of hackers are there, and what security policies are there in our organizations. Then how we provide the physical security to the organizations, we will be talking about that as well. Then on day 4, we will be talking about security again, and what common attacks are there, the steps of hacking. For hacking, what steps do you use, right? Now, working with Nmap. Nmap is a tool, so we will be working with that and how to use that. Then we will be explaining the threat actors. So what are threat actors? So we will be talking in terms of that as well, right? Now, on the day of conclusion, at the last day, we will be talking about some advanced topics like authentication controls, implementing network security appliances, how you will implement those, how you will protect your network. Then we will be talking about access controls, how access controls helps you in providing the security to the network, right? Now, next thing that we will be talking about is implementing secure network protocols. So what protocols we should use to have our secure communication. So we will be talking about that, right? Uh, Now guys, what we have is, the first topic we will be starting with is the network. Now, what is a network, guys? So I want if I ask you any question, so put that up in the chat. So what is a network, guys? Anyone? Okay, communication between multiple devices, connection between two hosts, connecting between two systems via internet communication. Correct. So what do we have as, guys? We have network. Now, network is what? As you can see over here, this is smartphone, this is a server, right? We have a router, we have mobile phone, and tablet and a computer. These all are connected to the router, and we are connecting to the internet, right? So our router is helping us to get connected to the internet, right? So what do we have, guys? We have this network. So network is what? Whenever two devices, minimum two devices, share their data with each other, and communicate with each other, that is called a network, right? Okay. Now, after that, what do we have, guys? there are types of networks, right? Now, before the types of networks, what we will be learning, we will be learning about the OSI model, right? Now, what do you guys understand by the OSI model? Anyone? What is OSI model? Now, OSI model stands for Open Systems Interconnection Model, right? Now, Open Systems Interconnection Model tells you that how the data will be transferred from one device to another. What standard do we use? So what happened, guys, back in the old days when there was no OSI model, we were using ARPANET, right? So does anyone knows about ARPANET? What is ARPANET? Okay, so let me tell you guys, right? So ARPANET was what? ARPANET was a protocol before, a model before that we were using, right? So what I have is, I have this OSI model, right? Now when ARPANET was not there, Department of Defense of US, they created what? They created the OSI, the ARPANET, right? And in ARPANET, what happened? In ARPANET, your designing was done, right? So what we were doing designing on that particular thing, the designing of the network. Now what back drawback was there? If we talk about ARPANET, so the drawback was, if I have a, let's say I am using a Mac operating system, right? I'm using a laptop with Mac operating system. So I was not able to communicate with the Windows operating system PC, right? So that was the drawback over there, right? So what I did, we came up with a model, we needed a model that will tell us that a standard for every device of every vendor, because there was vendor barrier. So we came up with the TCP/IP model and OSI model, right? Now, OSI model has 7 layers, as you can see in your screens. 7 layers. We start the counting from the layer 1, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application, right? Now, every layer has a different work while sending the data, right? So what do we have? We have this OSI model, and this in this we have different working of every layer. So what is the work of your application layer? So if I talk about application layer, your application layer is your GUI, graphical user interface. Anything that you can see, that is your application layer. Clear, everyone? Now, next thing that we have is presentation. So in presentation layer converts the data into a form that other layers can understand. Also, it does what? It encrypts the data so that no unauthorized access on the data can happen. Right? Now, next thing that we have is session layer. Now, session layer does what? Session layer of my sender, my sending system will do what? My session layer will be communicating with the session layer of your receiving system. And it will start a session with it. It will give it a path that I want to connect with you. So it will be connecting with the session layer of your receiver system. Now, next thing that we have is transport layer. So in transport layer, what happens? Transport layer does the segmentation of the data. So the data that presentation layer has encrypted, it is segmented by transport layer. So we break the data into different segments, and then what we do? We move every segment, we send every segment towards the network layer. Now, when the data arrives at the network layer, the data will be doing what? Your IP addresses will be added with the data. Right? Now, when the IP addresses will be added with the data, then after that, that data will be moved to the data link. Now, data link layer will be doing what? In data link layer, what happens? Data link layer works with the MAC addresses. So MAC addresses are what? Media access control address. That is your physical address. Right? So your data link layer will be doing what? Your data link layer will be sending the data towards, after adding the MAC addresses, it will be sending the data towards physical layer. Now over physical layer, what is happening? Your data is changed into bits. Right? Now if your data is changed into bits, then it will be transferred from the physical medium or wireless medium. Now there is a thing, guys. If you are using wired network medium, right? If you are transferring the data through wire, so that is what? That is your physical medium. So the data will be sent in bits. Right? Now if I have wireless media, right? So if I am sending the data wirelessly without the use of any wires, what will be happening? Your data will be sent in the form of radio frequencies. Right? So it depends on the medium, what medium we are using. Clear? Now, next thing, when the data is received by the physical layer of your receiver. So at the physical layer, what happens? At the physical layer, your data is changed again. It is converted again so that other layers can understand that. So it is changed in the form, like it can be in digital form or it can be in analog form. Right? So the conversion that happens on physical layer is digital to analog or analog to digital. Right? Now after that, it moves to the data link layer. So at the sender's end, the data link layer does what? The data link layer was adding MAC addresses. Now at this point, your data link layer is doing what? Your data link layer is checking the MAC address if the MAC address is matching or not. Right? Now if the MAC addresses are matching, what can I do then? Right? So if MAC addresses are matching, it will shred the portion that have the MAC address. Clear, everyone? So it will do what? It will shred that portion, that yes, I have checked this bit, that Now I will shred this portion, and now we will be doing what? We will be checking the other portion, right? Okay. Now after that, after checking the MAC address, we will move on to the network layer. Now on network layer, what will be happening? On network layer, your IP addresses were added at what end? At your senders, at your senders network layer, right? So from senders network layer, your IP addresses were added. So at your network layer of the receiver, what will happen? Can anyone tell me? It will be checking the IP addresses of that, right? So it will be doing what? It will be checking the IP address, that if the destination IP address is correct or not. So let me tell you this whole thing with an example, right? So as you can see over here, I have this. Now what is happening over here, guys? What we have is, we have application layer. So let me write it in front of it. Application layer gives you the GUI. Presentation layer is doing what? Encryption. So it is encrypting the data. Session layer is doing what? Session layer, the work of session layer is to manage the session. Now transport layer is segmenting the data. Network layer is working with IP addresses. Data link layer is working with MAC addresses, right? Physical layer changes the data into digital or analog, right? So these are the two things that we have, right? So when the data, let's say I have a data which says, let's say hello, right? I want to send hello. So what will be happening? I will be writing hello over here at your application layer. Now after application layer, the data will be encrypted. So encryption, what will be happening? Your hello will be encrypted, right? So encryption means changing something into gibberish, right? So that is what, that is your encryption. Now next thing that we have is, next thing that we have is session layer, right? So in session layer, your session will be started, right? So at the session layer, your session will be started, and it will be communicating with the session layer of your receiving system, right? So your receiving system will be communicating, both the session layers will be communicating that yes, I want to start a session because I have some data I want to share it with you. Now at the transport layer, the data will be broken into different segments. So how the segmenting would be done? That like E, L, H, L, O. So these are 5 segments that transport layer has broken it into. Now after that, what I have is, guys, your network layer. So one segment will arrive at the network layer. Now and at network layer, what will be happening? One segment has arrived. Now what I will be doing, I will be adding, the network layer will be adding the IP addresses, right? So the IP addresses will be added like this. This is our data E, the first segment, right? Then what we have destination IP and source IP added, right? So destination IP and source IP will be added for telling where the data will go and where to send the data, right? Now after that, this whole thing will arrive at data link layer. Now at data link layer, what will happen, guys? At your data link layer, your data will look something like this. Let me draw it over here. So your MAC addresses will be added. So destination MAC, source MAC, destination IP, source IP, right? And the data that we have. So these things will be added, right? Now after adding these things, we call it a frame. What we call it? We call it a frame, right? Now what else that we have? When the data arrives at network layer and your IP addresses are added, so this chunk is known as packet, right? Now packet is sent to your data link layer, and at the header of your packet, your destination MAC and source MAC is added. Now when the destination MAC and source MAC is added, then it is called frame. Now after that, that frame is forwarded to physical layer, right? Now physical layer will be doing what? Physical layer will be changing that whole frame into bits. And when bits, when I am sending the data through wire. So wired, I am sending the data bits in the form of bits. If I am using wireless, so the data will be shared in the form of radio frequency. So the data will be shared in the form of radio frequency, right? Clear, everyone? Right? Okay. Now this is the thing that happens. Now when it arrives to physical layer of your receiver point here, what will be happening over here, guys? Your packet that we have, your frame, so your frame will be arriving at data link layer of your receiver. Now from that frame, the receiver's data link layer will do what? It will check that if the destination MAC and source MAC is matching or not. So first it will check what? The destination MAC, because it is the address that we have written while sending the data that go there. I want to send my data over there. So what I will be having? I will be sending the data through the data link layer by adding destination MAC. Now destination MAC is checked and it matched that yes, it is matching from my. So next it will check the source MAC. Source MAC is also matched. Now we are left with destination IP and source IP. So what the data link layer of your receiver side will do, it will shred this portion. So this portion is checked and it will be shredded, it will be removed, right? Now after that we are left with a packet. So from here to here we are left with this thing only. So this thing will do what? This thing will be moved towards network layer. Now network layer works with the IP addresses. So what it will do, it will check the destination IP and source IP. If the destination IP is matching to mine or not. So if it is matching, it will check the destination IP and who sent that data, and it will remove that portion, remove this portion, and we are left with only the segment E, the first segment, that is E. Now what we will do, it will be moved towards your transport, right everyone? Now transport layer got E over here, right? After waiting, the same process will happen with every segment. Now with L, so here L will be there. After removing E, L will be there. So your IP will be added with L, right? Then your destination MAC address and source MAC address will be added with the L, right? So that is the thing. Same process will be happening. So at transport layer will be waiting for everyone, right? So transport layer will be waiting for every segment to arrive, right? So first E will arrive, then L will arrive, then H will arrive, then L again, then O. So all these segments will arrive. So then transport layer at your senders and did what? It did the segmenting. Now it will do the reassembling of the data. So it will reassemble that. Now after the reassembling, it looks like what? It looks like this, right? Now it looks like this. Now what we will do, guys, we will move that data towards the session layer. Now session layer got to know that what is happening. I got the data is received. So session layer will do what? Session layer will close the session over here, that I have received the data. Now it will be good that if we close the session, right? Now after that, what we have, session layer will forward the data to the presentation layer. Now at the receiver's end, your presentation layer will do what? It will do the decryption. So it will decrypt that data, right? Now the data will be decrypted, right? So it will in the form of hello again. So it will be back in its original form. Now that will be sent towards your application layer, and at application layer your end user is sitting and he gets the data, right? So that is the thing that happens when you send the data towards your OSI model. Clear everyone? Okay, great. Now the next thing, great. Now the next thing that we have is, after OSI model we have TCP/IP. So if you guys can see in TCP/IP model, what I have is, I have these layers. So we will be comparing the OSI model with your TCP/IP model. So in OSI model, what I have is your application layer, right? Presentation layer, session layer, transport layer, network layer, data link layer and physical layer. Now, if you guys will see in TCP/IP model, what I have is I have application layer, transport layer, internet layer, and link layer. So it does not mean that presentation layer, session layer is not working over there. Data link layer is not working over there, right? So what is happening in TCP/IP model, guys? Your application layer has merged two more layers in it. So inside your application layer is working, your presentation layer is working, your session layer is also working, right? So that is your application layer. Now transport layer, as you can see, it's same, right? So transport layer we have. Now next thing that we have is network layer. So network layer is what? Network layer is your internet layer. So it is same, just the name is changed. So network layer is changed to the internet layer. Clear, everyone? Now next thing that we have is data link layer. So data link layer and physical layer are merged together and now they are called link layer. What other name do they have apart from link layer? It is also called network interface layer, right? So link layer is also fine. Your network interface layer is also fine, right? So we will be having all the working same, but just the number of layers are less because they have merged the layers, right? Okay. So these are your networking models, right? Okay. Now what do we have, guys? If we talk about it, we have topologies. So now what are topologies? So what do you guys understand by the word topology? So topologies, they tell us that how our network is designed and where our appliances are, where our devices are, and where our cables are deployed, right? Now, what happens is, guys, when we are talking about your topologies. So what is happening? Your bus topology is here. The first type of topology we will be talking about is bus topology. Now, in bus topology, what happens is there is a server, as you can see, there is a workstation, laptop, workstation, laptop, printer. And all of these things are connected to this single cable, this single line, right? So this single line is called the backbone. Clear, everyone? This single line is called what? The backbone. Now, why we are calling it the backbone? Because like the body weight of ours is taken care by the backbone of our body. So same like that, this backbone has the most of the congestion. So that's why it is called the backbone, right? So if I create a bus topology over here, right? So let's say we have a bus topology. These are the four devices, let's say, right? Now, what do we have, guys? We have this cable, let's say, right? And these are the PCs that are connected to this cable. Right now, what we have is we have this PC1, let's say, this is PC2, this is PC3, and this is PC4, right? Now we have these PCs. So what will be happening, guys? I have added two more things at the end, right? I'll tell you what these are. Now what happens, let's say PC1 wants to send data to PC3 or PC4, let's say. So PC1 will be sending the data. The data will be traveling in the backbone, and the data will be visiting this node. That thus this data is meant for you. Now, if that data is meant for PC3, that data will be doing what? That PC3 will be doing what? It will be checking the IP address of that data that is written and the MAC address. If the IP address and MAC addresses are matching, right, then what will happen? It will accept that data. Otherwise, it will deny that this data is not for me. Same like that, it will be happening with PC2. So if IP and MAC addresses of the PC2 are matching with those that are written in the data, then it will be accepting the data. Otherwise, it will be denying that this data is not for me. Now, if I talk about PC4, guys, so in PC4, what happens? PC1 wanted to send the data towards PC4, so the data will be traveling towards PC4, and PC4 will be doing what? PC4 will be accepting that data. So PC4 will be checking if the IP addresses, destination IP addresses and destination MAC addresses are matching. That's the real thing. And if it is matching, so it will be accepting the data. Now, Mr. Raki Haridos, that this is the real life example of your OSI or TCP/IP model. The data is being sent, it is being checked by the data link layer, and then it is being checked by the network layer. So data link layer is checking the MAC address and network layer is checking the IP address, right? Now, what we have is, guys, we have this thing, these two things at the end. So can anyone tell me in the comments that what are these? Why I have added these two blocks? Can anyone tell me what are these blocks? Correct. So this is called what? This is called the terminator. So terminators are what, guys? If we talk about terminators, let's say PC1 sent the data, it is received by PC4. But does that data knows where to, if the PC has got the data, if the intended PC has got the data or not? No, the data does not knows that. The work of the data is to travel. So it will be doing what? After visiting this node, the data will be traveling here as well. Now the data is traveling here. Let's say if there is no terminator. So data will do what? Data will strike this end and it will be reflected back in the backbone. So what will happen if we are not using the terminators? The data will reflect back and it will flow continuously in a loop in the data, right? So there will be a non-stopping loop that will be happening, that will be going around in this particular backbone, right? So this backbone We have this backbone only where the data transmission is happening. So let's say if this data is traveling continuously and PC2 sends the data again to PC3, let's say, right? So what will be happening? One data is coming from here, one data it is sending. So there will be a collision of the data. So for removing that, what we have is we have terminators. So terminators will tell the data that data, this is the end of the topology. Now you don't have to flow more. So it will be dropping off the data from here. So it will be terminating the data. So that is the work of your terminators. Clear everyone? Now next thing, if I talk about bus topology and if I talk about the advantages. So what advantages are there for bus topology? Anyone, what are the advantages? You guys can put your uh, outputs in the chat. Efficient, low cost, okay. Now it is very easy to connect, right? Installation is very easy, right? Linear architecture. So linear architecture means that it is very simple and reliable. Right? Now it is simple and reliable as well. Now it is scalable. So if I want to increase my structure, if I want to add more devices, as you can see, so I'll remove this terminator, I will increase the length of the cable, and then what I'll do, I will again do what? I will again connect a PC, and then at the end I will place an terminator. Right? So this is what? This is your bus topology. Now, if I talk about the disadvantages of it. So the disadvantages are the one thing that is there is security. So security is not there because your data is traveling to every node, right? What if in this node, in the place of PC3, there is an attacker sitting over here? So he will be able to sniff the data, he will be able to get the data, right? So that's why it is not secure. So security is a disadvantage over, right? Now, one more disadvantage is it is not good for large networks, right? Now, it is not good for large networks because the length of the cable will increase. So with that, with the increase in length, what will happen? Your speed will be slow, right? And what else will happen? It cannot handle more devices. So if more than one communication is going on in the network, so collision will happen, right? So it will be prone to collision. Correct, Mr. David? Right? Now, what else? What more disadvantage is there for bus topology? So if the backbone fails, everything fails, right? So what we have is this whole thing is dependent upon your backbone. So this is the backbone. If it breaks, the data will be traveling continuously. It will not be a bus topology again. So everything depends on the backbone, right? So that is also a disadvantage of it. Clear, everyone? Yes, it is non-reliable. Is it non-reliable, Ms. Varsha? I have written it in advantages. It is reliable. So the cables are very much. So it is what it is very difficult to do what it is very difficult to manage the cables, right? And the cost is very high due to a lot of cables. So it becomes very costly as well, right? Okay. So this is what these are the advantages and disadvantages of your bus topology. Now next thing that we have is star topology. So in star topology, as you can see, what we have is there is a switch or hub in between. So there is a centralized device in between in the star topology, and it is taking care of that. Because in your bus topology, what was happening, if the server is sending the data here, right? So if the server is sending the data will be sent towards the printer first, then the workstation, then laptop, then workstation, then another workstation, then to the laptop. So what if I want to send data to this laptop and this laptop is doing what? This laptop is at the end. So the data will be visiting every node, and after that it is reaching to the destination. So there are security issues. So for security issues, we have added a switch in between, right? So what your security people did, they added a switch in between. Now, if we are using a switch, right? So what will be happening if this PC wants to send data? So that data will be directly sent towards switch. Switch will check where the destination PC is. So let's say if I want to share the data from this PC to here, right? So what will be happening? Your PC1, let's say this is PC1, it will be forwarding the data towards the switch. Now the data will be forwarded towards the switch. Switch will be checking to which port this PC is connected to. So PC2 is connected to which port? Now, if it will be connected to port number, let's say 3. So it will be switch will be forwarding that data towards port number 3, right? And the data will be reached towards this PC, right? So what if let's see at over here again. We have this. Let's say these are the devices. Now what happens, guys? Let's say this is a switch and this is PC1, this is PC2, this is PC3, and this is PC4, right? So after PC1, like we have PC1 connected to the switch, PC3 connected to the switch, PC2 is also connected to the switch, and PC4 is also connected to the switch. Right? Now all these PCs are connected to the switch. So what will happen? PC will send the data towards switch. If I want to send it to PC4, so switch, the data will be received by the switch. Switch will be checking that in its CAM table. So what we have, there is a CAM table in your switch that stores the MAC addresses and the port number. So what will happen? Your switch will be checking that, and it will be doing what? It will be forwarding that data towards PC4. So the data is not going to your PC2 and PC3. It is not doing what? It is not visiting the node PC of PC2 and PC3. So that's why it is more secure. Right? Miss Fatima, you will be getting the recordings on YouTube. So at the end of the lecture, I will be providing the link as well. So don't worry about that. You will be getting the recordings as well. Now, guys, if I talk about the advantages and disadvantages of that. So what are the advantages of your star network? Security, Ms. Preeti, security is the disadvantage, right? Now, if I'm talking about the advantages, so it is fast, right? Speed is there. Now, easier to put in, right? It is easier to implement. You have to just connect all the devices to the switch, right? No collision. There can be a collision, Mr. Manna. Now, is it costly or less expensive? So it is less expensive. So what is happening? We are using only one switch in between, and all the devices are connected to that particular switch. That makes it less expensive. Now fault detection is easy. So what happens, guys, if let's say I'm not able to send the data towards let's say PC3 is not able to send the data to PC2, right? So what happens? Where the fault can be? You guys will not check this wire. You guys will not check this wire. You guys will check either this wire or this wire. So fault detection is very easy. Now, Mr. Gyanendra, it depends on the number of ports that a switch has. So switch can be 8 port switch, it can be a 48 port switch as well, right? So there are 24 port switch as well, you have 48 port switch as well. So it depends on your requirement what you need. Now if we talk about the disadvantages, guys, can you guys see any disadvantage of star topology? Correct. If switch fails, everything fails. The whole topology fails, right? Correct. Now what else? It requires more cable. As compared to your bus topology, switch in star topology, it requires more cables, right? What else? The performance is also based on the centralized device, right? So the performance of this topology will depend directly on this device. It is dependent on that, right? So that is your star topology. Clear, everyone? Yeah, it's a little bit costly. Muhammad Abdul Rakib. That is a bit costly. Now security is a disadvantage in yeah, in your bus topology. Mr. Afan. In your bus topology, what is happening? Your data is traveling to every node. The data is visiting every node. So that's why security is the disadvantage. Clear, everyone? Okay, great. So the next thing that we have is ring topology. So in ring topology, what happens? Correct. Token is passed. So in ring topology, we have token passing, right? Now, what happens, guys? Every time there is a token going around. So if you guys will see, it will start roaming around, right? So token is going around in this topology every time, right? Now, whoever in this particular topology, any device who has some data to send, it will stop the token and it will fill that token with the data, right? So there was token flowing and that token was stopped by PC1. Now PC1 filled some data in it and sent it towards PC2, then PC2 forwarded it to PC3 and PC3 forwarded it to PC4 and PC4 and then same like that wherever you want to send the data, right? Now this is the thing about your ring topology, right? Now what happens, guys, in this ring topology, can you guys tell me the advantage and disadvantage? So if I have a ring topology, I have this ring, and I have connected all the devices here. So this is device 1, this is device 2, this is device 3, and this is device 4, right? So if I have connected these devices to a ring, so they are connected to each other adjacently, right? Now what we have is we have PC1, PC2, PC3, and PC4, right? So what happens, guys, your device that we have, let's say the token, we have a token, right? In this particular topology we have a token. So let's say I have this token. So with the blue color we have a token. Now this token is constantly continuously flowing in this particular topology. Now what happens, guys, when let's say PC3 has some data, so PC3 will stop that token and it will fill the data in that token, right? Now what happens, the PC3 wants to send data to PC2, so fill that data with the address and the data, so it will be sharing the data with PC4. Now PC4 will be forwarding the data towards PC2. So that's how it works. Now everyone is saying it's not secure or secure. How you are saying that? So if it is secure, how it is secure? If it is not secure, how it's not secure? Anyone from the team? You guys can put your comments. See guys, my data is traveling to every node again, right? My data is traveling from PC3 to PC4 and PC4 to PC2. So what if this is an attacker sitting over here? So it is not secure. Now it's also slow. We have to wait for the token as well. Then we have to fill the data, and after filling the data, what we have to do? We have to wait for it to reach, right? So when the data, what if I have just direct connection? It will be much more faster than it, right? But I don't have this direct connection. I have what? I have this PC, this PC to PC connection. So adjacent connection is there. So if I talk about the advantages and disadvantages of it, what are the advantages, guys? Can anyone tell me what are the advantages of ring topology? Everyone quickly in the chat, please. Prone to man in the middle attack. Okay. Now, can there be any collision, guys? Collision of data. If I talk about collision, so less chances of collision. Now, why there are less chances of collision, guys? What I have is, first thing I have token. So if you have token only, you can send the data. Now token is sending the data, right? Second thing, the data is traveling in clockwise format. So the data is traveling in the clockwise format, even if even if there is one more transmission going on. This PC1 is sending data to PC4. Even if PC2 sends the data towards PC3, so at that time when PC2, PC1 will be sending to PC3, PC2 will be sending it to PC1. Now PC3 will be sending it to PC4, PC1 will be sending it to PC3. So no collision will be there. Less chances of collision, right? Now is there speed or is it slow?
It is slow.
Okay. Now what about the management? If I want to add one more device in this topology, how is it easier to add one more device, or is it very difficult to do that? Yes, correct. So it is easy to manage. Now if I want to add new device in this, so what I have to do, I just have to break the code in the between and add a new device. Yes, Mr. Diego, we have to take the network offline for some point of time and for a while, but it is easy as compared to other topologies, right? So in other topologies, we have to connect to them and do a lot of stuff, but over here we just have to break the cord in between and we just have to connect our new device and it will be connected, right? Okay, great. Now next thing, next advantage, anyone can tell me? No need of the server. So there is no server in between that is managing this whole topology. Every device is its own server. Every device is actually managing its own resources, what to share, what not to share, right? Now next thing is easy fault detection, correct, Mr. Raju? Now easy fault detection means, guys, we have, let's say there is a fault in the wire. So if I am sending the data from PC1 to PC4, the data reached to PC3, but it hasn't reached to PC4. So what happened? Where is the problem? The problem is here in this place of the wire, right? So what I'll do, I'll change this wire and then it will start working fine. So I just have to know where the fault is. It will be very easy. Clear? Okay. let's talk about the disadvantages. Now, if I talk about the disadvantages, guys, so disadvantage is, what is the disadvantage? Security, because my data is visiting every node. Now, what other disadvantages are there? Performance will be slow. Okay. Now, if one system fails, the whole topology will fail. Agree, everyone? If one system is failing, if the whole topology is failing. Now it is slower as compared to your bus topology. It is slow. Is it expensive, guys? Yes, it is expensive. Nice answer, Mr. Sidhu. Now what else? So one more disadvantage which I'm not writing, but I will tell you that if I want to send the data, I'm sending the data. So every PC must be switched on. Right? If PC3 is switched off, then we are not able to transfer the data towards anyone. Right? So that is also a disadvantage, that what if one PC is offline or it's shut down, that it will not be able to send the data. Clear, everyone? Okay. Now moving on to the next type of topology, that is mesh topology. Now it is pretty clear, guys, and it is you guys can see that topology in front of you. I have 6 devices in my topology, and every device is connected to each other directly and also indirectly, right? So if you will see about this PC, so this PC is directly connected to this PC. Indirectly, it is also connected to this PC in many ways, right? So what happens, guys? If if any of the path is faulty, if any of the wire out of these is faulty, it will take another path, right? So what I'll do, I'll create it over here. I have these 4 devices, right? Now every device is connected with each other. Now every device is connected with each other directly and also indirectly, right? So this device will be connected to this one as well, right? This device is connected to this one as well, right? It is directly connected to this. Now this is the connection that we have in mesh topology. Every device is interconnected with each other. Now guys, what we have is high reliability, right? So we have this PC1, we have this PC2, we have this PC3, and we have this PC4. Right? Now what the things are, guys, if PC1 wants to send data to PC4, it has a direct link. It will be directly sending the data towards your PC4. Right? Now what if this wire is not working? This wire became faulty. So what PC1 will do, PC1 will forward that data towards PC3 and PC3 will forward that data towards PC4. This is also a point. What if this wire is also faulty? So PC1 will be sending the data towards PC2 and PC2 will be forwarding it to PC4. Right? So there are redundant links as well. So what do you guys understand by redundant links? Any link where the destination has two paths, right? So for reaching destination, if I have two paths, so that is your redundant link, right? Now, if I ask you guys, what are the advantages and disadvantages of mesh topology? Advantage, guys. First, I want advantages, then disadvantages. So, if there is a failure in wire, failure in wire will not stop transmission. It will take some other path, right? Okay. So, high privacy and security. Direct links. We have the direct links to send the data towards other person, right? Now, no centralized device. So there is no device that is doing what? That device is managing the all of the devices. So no centralized device is there. Now is fault identification straightforward or not? Yes or no, guys? If I talk about fault identification, if I want to identify the fault, so fault identification is easy or not? It's straightforward, right? Not easy, but fault identification is straightforward, right? Now you know that if one PC is not able to directly send data to second PC, so the wire is faulty in between, right? The changing and managing and the maintaining of that is very hard, very tough, right? Okay, great. Now, as Miss Kalpana said, that easy to add new device, so that is also an advantage, right? Now, if I talk about the disadvantages, what it can be. What can be the disadvantages of this particular topology? Installation is difficult. Because there are a lot of wires in every PC you have to connect to other PCs by different wires. So in every PC there will be, if there are 15 devices in the network, so every PC will be connected to other 14 and it will require a different wire, right? So is it will be costly as well, because we are using a lot of wires as well, right? Now if we have lot of wires, so power consumption will be very high, right? Now what else we have? High risk of redundant connections we have, right? Now maintenance needs are challenging, right? So there is a high maintenance because lots of wires are there and you have to take care of all of them. If any one of them is faulty, then you guys will be doing what? You guys will be changing all the things, checking all the things, right? So if you have an office and you have implemented this mesh topology, so you have to move all the furniture from here to there, and then you have to check what things are there where the wire is faulty and change that wire, right? You will find out, you will identify the fault very easily, but the maintenance part is very difficult, right? Okay. Now, after mesh topology, we have hybrid topology. So now hybrid topology, we implement hybrid topology on the needs of us. So that is our need, whatever our need is. So we have hybrid topology for that. Now in hybrid topology, what happens? It is a combination of two or more topologies. So as you can see, ring topology is over here, hub and star topology is over here, and then bus network is over here. So when we want more things, right? If our need is something else, only one topology, after implementing only one topology, it's not giving us that required desirable output. So what we use hybrid topology, so that in different parts of the network, different topologies we have implemented, right? Now if I talk about the advantages and disadvantages of the hybrid topology, so that those will be same. Like if we have star network, so advantages for star topology will be same, disadvantages will be same. Now if I talk about the ring topology, so for ring topology, security will be there, security is the disadvantage. Same like that for bus topology, security is the disadvantage. So the disadvantages and advantages are same on that. Whatever topologies you are using in the hybrid network, disadvantages and advantages depend on that, right? Now we have discussed about star topology, mesh topology, bus topology, ring topology. Out of those topologies, which one is the fastest, guys? Which topology you can say it is the fastest one? Is it star? Is it mesh? It is ring? Or is it bus? Which one is the fastest topology out of all, guys? Okay. So the fastest topology that we have is your mesh topology because we have a direct link connected to every PC. So if I want to send the data, it will be directly sent to the receiver. Now, which topology is the most used topology out of all? So out of all of these topologies, your star topology is the most used topologies, and we implement these topologies in the organizations, right? So guys, this was about your topologies. Now we will talk about local area network, metropolitan area network, and wide area network, like types of network. Now, as we saw all the things, these topologies, are implemented in your local area network. So what is local area network? As you can see, all the devices are connected to this particular server. So when we are connecting to a particular server, and that server is giving us services, so that is local area network. Local area network is always implemented inside the building or inside small offices. It is not outside the offices, only inside the building. So in even in the building, if you have your organization and your organization is occupying three floors, like one floor is there, this is the architecture in that, then next floor same architecture, then next floor the same architecture. So what will happen, guys? That is also a local area network. You are not going out of the building. Your office is in the same building. You are just moving upwards, you are growing upwards. So that is the same thing. It is a local area network, right? So that is your local area network. Now, next thing that we have is metropolitan area network. Now, metropolitan area network, guys, what if we talk about metropolitan area network? So in metropolitan area network, what we have is we connect different LANs together. We connect different local area networks together, right? So your metropolitan area network, as the name is suggesting, your metropolitan area network gives has the range of 50 to 100 kilometers. So when you are communicating within the city, only inside the city, that is your metropolitan area network. So what we have, your LAN 1 is your hospital local area network, your LAN 2 is college local area network, LAN 4 is school local area network, and LAN 3 is your factory local area network. So these all are connected with each other, they are accessing the internet. So that is what peoples from that city are accessing the internet. So that is your metropolitan area network. You guys are just communicating within the city, not out of that city, right? So that is your metropolitan area network. Now after that we have wide area network. So as you can see, what we have primary side, third party vendors, internet, we have data center, we have different homes, we have VPN. This home is connected to the internet using VPN. So wide area network is what, guys? Basically, if I talk about wide area network, so the biggest wide area network is what? Can anyone tell me which one is the biggest wide area network? So the biggest wide area network is internet, right? So if we talk about that, your internet is the biggest wide area network. Now we have two types of internet, guys. We have internet and we have internet. So can anyone tell me the difference between these two internets? Anyone from the team? No one? So internet is what, guys? The www that we use, the World Wide Web, where your billions of devices are connected and communicating with each other. Correct? Now the second internet with a lowercase I, the small I, that is what when two devices are communicating with each other. Right? So when two devices are communicating with each other, that is called internet. And when we have a uppercase I, so that is your World Wide Web. Right? Clear, everyone? Okay. Now, when we add when we add domain names with wide area network, that becomes your GAN. GAN stands for Global Area Network. So if you are accessing any website, so that website you are accessing, it is not wide area network, it is a type of wide area network, and that type of wide area network is known as global area network, because we have added domain names. If you are accessing Google, so that is called what? That is called your global area network. Clear, everyone? Okay. Now moving on to the next bit. Now what we have? We have networking devices, guys. Now in networking devices, the first device we will be talking about the basics, the devices that we need every day in day-to-day life in our organization. So what we have hubs, right? So if I talk about hub, so in hub what happens is hub is a device that is used to connect more than two devices together, right? So what if I have a hub over here, right? Now with this hub, let's expand it. Now I have these devices added. Now these are the devices that are connected to the hub. So this is PC1, this is PC2, this is PC3, and this is PC4. Now what happens with the hub, guys? PC1 is connected to the hub, PC2 is also connected to the hub, PC4 is connected to the hub, PC3 is also connected to the hub. Now, when PC1 sends the data is broadcasted in hub. So the characteristic of the hub, the working of the hub is it does what? It broadcasts the data. Now tell me guys, if you are sending a message on WhatsApp and that is a confidential message, you are sending your trade secrets to your manager. And what if all those messages are broadcasted and sent to everyone that is present in your contact list? How will you feel? Same like that, this thing happens in the hub. So the thing that we discussed in bus topology, that PC1 is sending data, right? And it is the data is visiting every node. So same like that, it is happening. So what happens if PC1 is sending data towards PC4? So PC1 will send the data to the hub. Hub is a device that works on physical layer. So physical layer of the OSI model, your hub works, right? Now on that physical layer, I discussed with you guys that on physical layer, it only works with bits. So the PC1 will send the data will be converted into bits. Hub will be doing what? Hub will be broadcasting that data towards everyone, right? Now everyone will be having that data. So again, the OSI model will be implemented. Your data link layer will check the MAC address, right? MAC address will be checked. Your IP address will be checked. Now, IP addresses and MAC addresses will be checked. So PC3 will say this does not belongs to me. PC2 will say this does not belongs to me. But PC4 will say yes, it belongs to me. Now, what if now I'll tell you that there is a hacker sitting at PC2, right? What he did, who is checking in our system that if the MAC addresses and IP addresses are matching or not? Who is checking that? So it is checked by your network interface card, NIC. So NIC is what? NIC is your network interface card, right? Now network interface card does what? It takes care of the IP addresses, it takes care of the network as well, that how you will be connected to a network. Now it is checking. Now always remember guys, network interface card works in managed mode, right? In which mode it works? In managed mode it works. So in managed mode, what it does, it checks the IP addresses, it checks the MAC addresses. Now if it is not checked, what if I make it that not to check the IP addresses and MAC addresses? What if I make it like that? So that will be done, like I will change the mode of working of my network interface card. So from manage mode, I will make it to promiscuous. So in promiscuous mode, what happens? Your checking of IP address and MAC address is removed. So it will not check for any IP address and MAC address. It will, even if the data is not meant for that PC will be accepting that data. So hacker can do that. Now how hacker can do this thing? How we can change the data from managed mode to the promiscuous mode. So there is a tool guys with the name Wireshark, right? So I will be showing that tool to you guys in the further sessions when we will be learning about security. So that Wireshark tool does what? That Wireshark tool is a packet capturing tool. So if the data is traveling in the network, Wireshark can do what? Wireshark can capture the data in between. Right? Now what it will do, guys, with Wireshark, whenever you download a tool with the name Wireshark, there is a utility downloaded that is called WinPCap. And this WinPCap utility helps the attacker to change the working of network interface card from managed mode to your promiscuous, right? So this is how you change your network interface card from managed mode to promiscuous. So there were security issues with the hub. That's why we moved to the switches, right? So next thing that we will be talking about is switch. Now, as you can see, guys, in the star topology as well, we discussed about switches. That in switches, what happened? Your data is directly transferred to the intended device. So if I want to send data from PC1 to PC3, I will send that data to the switch and switch will be forwarding it towards PC3. Now, how switch finds that out? Can anyone tell me? Okay, let me tell you guys. So what we have is, guys, we have, let's say there is a switch again, right? And the devices are connected to it. So this is PC1, this is PC2, this is PC3, and this is PC4, right? Now these devices are connected to the switch. Now what I said, switch has a table. And what is the name of that table? That table is known as scan table. Right? Before that, we should know what is MAC address. So it works on MAC address. So we have a switch. This is PC1, this is PC2, this is PC3, and this is PC4. Right? So what happens is, guys, switch has a table with the name cam table. Right? What is the name? CAM table. Now CAM stands for Content Addressable Memory Table. So in that table, it looks something like this, and in that table, your MAC address is written and the port number is written. Right? So let's say PC1 is connected to port number 1. Right? So F0/1 we will be talking about, right? PC2 is connected to F0/2, PC3 is connected to F0/3. These are the port numbers, right? F0/4. So in the MAC address, let's say PC1 has a MAC address of AAAA, PC2 has a MAC address of BBBB, PC3 has MAC address of CCCC, and PCB has PC4 has DDD. So what is written over here? MAC address AAA is connected to port number F0/1. MAC address BBB is connected to F0/2 port number. MAC address CCCC is connected to port number F0/3. MAC address DDDD is connected to port number 0 slash, right? So what will happen if PC1 is sending the data towards the switch will do what? Switch will check its CAM table that where is MAC address DDDD. So in the data, when we send the data, we write the MAC addresses, right? So DDDD we have. So inside it, switch will find out where is DDDD. So he found that DDDD is connected to port number 4. So switch will forward that data towards port number 4, and that data will reach PC4 without other nodes, right? So this is how your switch works. Clear, everyone? Now, on which layer your switch works? Your switch works on layer 2 of OSI model, which is data link layer, right? Okay. Now, next device that we will be talking about is router. So what happens is, guys, uh, same example we will take of switch. We have this switch, right? And this is the network of it. Now, let's say the IP address of this particular device is like 192.168.46.131, right? The second device is .132, the third device is .135, and the fourth device is .137, right? So these devices are there with these IP addresses, right? Now what I have a same network over here. I have one more network with these devices, right? There are these four devices. They are also connected to the switch. And what is happening over here, guys? This, right? So we are connected to the switch. Now this is switch, and this is PC anything, PC5, PC6, PC7, and PC8. So let's say the IP address of this PC5 is uh, 172.254.16.11. Then it is .12. Then it is .13, and then it is .17. Right? Now switches work on MAC addresses. But if there are two different networks, so this is a different network because this network is inside 192. This network is starting with 192 and this network is starting with 172. So what we need for making these both two topologies, these both two networks communicate, we need a router in between. So what do we have? We have this router in between. So router will be connected to this switch as well, and this router will be connected to this switch as well. Now when it will be connected, now you can transfer the data from one network to another, right? So that's why switches do what? Switches only work with data link layer. So that's why we need a router in between, and router helps us in getting the access to that particular different networks, right? So if we have two different networks, so if we want to make them communicate, so we use routers. So that's why we have routers in our home. So our network will be able to communicate with someone else's network outside the internet using the router. Now router does what? Router works on layer 3. So router is a layer 3 device and which is network, right? So it only works with IP addresses. Right? So this is the working of your. It takes you to the internet, makes you communicate with other departments or other networks. So that's how your router works. Right? Now, next thing, we have IP addressing. Right? So in IP addressing, what happened, guys? Back in the old days when IP addressing was new and your internet was young, so what happened? Your IP addresses were broken into classes, and that was called your classful IP address. Now, what those classes were, these are the classes. Class A. So IP addresses starting from 0 to 127 are in class A. Then in class B, the IP addresses starting from 128 to 191. Then in class C, we have IP addresses starting from 192 to 223. Then in class D, we have IP addresses starting from 192 to 223. Then in class D, we have IP addresses starting from 224 till 239. And in class E, we have IP addresses that are starting from 240 till 259. Right? Now, what we have is IPv4 address notation. So IP address is of 32 bits. Everyone knows. 4 octets are there. So every octet is of 8 bits. Right? So 8 plus 8 plus 8 plus 8. Right? Dotted notation looks like this. XXXXX. Anything can be there. Dot XXX, dot XXX, and these things. Right? Now, it IP address looks something like this, like 166.75.229.22. So how we did the IP addressing, guys? Now, if we talk about the classful IP addressing, right? So in classful IP addressing, what do we have is we have classes, right? So we discussed about the classes like class A, we have class B, we have class C, we have class D, right? And we have class E as well, right? So we have these classes. So in these classes, we have different IP addresses, and IP addresses are 0 to 127, right? And 128 to 191, and then in class C 192 to 223, then in class D 224 to 239, and in class E starting from 240 to 255, right? Now out of 0 to 127 in class A, 1 to 126 are usable IP addresses. 127 is your loopback IP address, right? Loopback means you are just pinging your own system. So if I click on here, I open the command prompt and I write ping 127.0.0.1. So I will be getting a reply and I am just pinging my own system. And if you are able to ping this system, if you are able to ping this IP address 127, that means TCP IP protocol is perfectly installed in your machine and you are able to do what? You are able to access the internet, right? Now we have something with the name called subnet mask, right? Subnet mask does what? Subnet mask separates your network bits and the host bits. So what we have is the network, the subnet mask for class A is 255.0.0.0, right? Now for class B it is 255.255.0.0, right? Now next thing that we have for class C, so we have 255.255.255.0, right? We only use class C, class A, B and C. Class D is used for multicasting, right? So what is multicasting, guys? Multicasting means, like if you are like it's a newspaper subscription. So if you are subscribed to the vendor of the newspaper, that newspaper vendor will be doing what? That newspaper vendor will be giving you the newspaper. Otherwise not. If you are not the part of his network, or if you are not subscribed to him. So same like that, we have a multicasting group. You have to be the member of that, right? So that is your multicasting. And 240 to 255 are used for experiment purposes, right? So what we will be doing, guys, I will be telling you how you will find the subnet mask, how will you find how many devices will be added, right? So I will go with the IP address of, like, let's say my IP address is 192.168.46.1, right? Or .46.0. So what I have to find out that how many devices I can add in this particular subnet, right? Now subnet is what? Subnet is a small part of a network. So what I will be doing, guys, first I will find out the subnet mask. So as I can see is it is starting from 192. So the range of 192 falls in class C, and in class C the subnet mask is this. So I will write down the subnet mask 255.255.255.0. Now what I'll do, guys, every time we do the calculations, we do the calculations in the subnet mask, right? So what I'll do, I'll write it like this: 1, 2, 3, 4, 5, 6, 7, 8. Now 8 octets. This is of 8 bit. This is of 8 bit. This is of 8 bit, and this is of 8 bits. So 4 octets are there. So for every octet we will create 8 bits, right? Now 1, 2, 3, 4, 5, 6, 7, 8, right? Same like that for other two. 1, 2, 3, 4, 5, 6, 7, 8, right? Dot 1, 2, 3, 4, 5, 6, 7, 8. Now 8 bits are there for everything, right? So what I'll do, what we do first, we start the counting. So how we write the counting? We write the counting like this: 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4, 2 raised to the power 5, 2 raised to the power 6, and 2 raised to the power 7, right? Now what is 2 raised to the power 0? I'll write it over here like 1, 2, 4, 8, 60, 32, 64, and 120. Same like that, what we have here as well: 1, 2, 4, 8, 16, 32, 64, 120. Then again 1, 2, 4, 8, 16, 32, 64, and 120. Now, if we have to find out what bits are on and what bits are off. So your on bits are your network bits, right? And your off bits are your host bits, right? Now your on bits and off bits you came to know, right? Now what I'll be doing, guys, I can see that if I put all the bits on in an octet, so what will be the sum of that? We have to add all these things that we have written below, right? So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. These all added together make 255. So that's why in our subnet mask we have 255. Now in the next octet we have 255 again. So we know that all the bits are on. So we will put all the bits on. Now in the third octet as well, all the bits are on because it is 255 written. Now in the last octet, what do we have? We have 0 written. So that means no bit is on. So I'll do what? I will just write 0, 0, 0 at all the places. Now what we have, guys, for finding out the host, we have the formula that is 2 raised to the power n minus 2, right? Now n over here is number of zeros. So number of zeros, how many number of zeros are there? All are 1, only here are zeros. So 1, 2, 3, 4, 5, 6, 7, 8. So what is the formula now? 2 raised to power n. So n means 8. 2 raised to power 8 minus 2. That means 256 minus 2, which is 254. So you will be having 254 IP addresses in this particular subnet, right? So you can have 254 devices added, right? So what if I want to add only 30 devices? So your what will happen? Your I'm getting 254 IP addresses. I wanted to add 30 only. So we came up with your classless IP addressing. Now in classless IP addressing, guys, what happened? Your classless IP addressing has CIDR notation. So in CIDR notation, if I talk about, CIDR stands for classless inter-domain routing. So in CIDR notation, your subnet mask that we are talking about, it is not static, it will be dynamic, so you can change it. And you write the subnet mask in the form of slash. So /8 because 8 bits are on over here. Only one octet has 255, that means 8 bits. Then again for class B it is /16 and for class C it is /24. Right? So what I'll do, guys, when I did this, now in CIDR I can change this particular thing, right? So I wanted how many devices? I wanted only 30 IP addresses. So I'll remove that, and what I'll do, in place of these zeros, I'll put these bits also 1. So these bits are now 1. So if now I will find out the IP address, then it will be, the host will be, again if I put the formula, so the formula will be 2 raised to the power n minus 2. So 2 raised to the power 5 minus 2, which is 32 minus 2, which is 30. Now I am getting 30 IP addresses. Now there is no wastage of IP addresses. So that's why we moved toward classless IP addressing. So this was your classless IP addressing where you were able to change the subnet mask. Clear everyone? Okay. So this was about your classless IP address, right? So we have still 10 minutes left. So if you guys have any questions, you can ask the questions. You can put them up in the chat. And these are the links, guys. That links you will be getting. So for Telegram you have this link, for YouTube you have this link, and for LinkedIn you have this link. So for this training of 5 days, guys, for this webinar you will be getting the certificates, and for those certificates you have to fill the feedback form, and you will be getting those feedback forms in this particular links, right? So I will be sharing, if you guys want you can write those links, copy those links, or I can drop these links in the chat as well, right? So if you want I can put them in the chat. So if you guys have any questions, any queries, you can put them in the chat as well, right?